Thanks. So I suppose you're all JavaScript developers, right? Otherwise, you probably wouldn't come to a JavaScript conference. But let's just do a quick show of hands. Who of you has ever dealt with strings in JavaScript before? Yeah, I should be seeing all your hands. And who of you has ever dealt with regular expressions before? Yeah, still a lot of people. OK, so this presentation will probably be of interest to you, because we're going to be talking about a couple of new features that recently made it into the JavaScript language. In ECMAScript 6, every regular expression instance has a Unicode property, well, a Unicode getter, which explains the title of this presentation. And this getter returns true or false depending on whether a new flag to the regular expression was set. And this new flag is the Uflag, which of course stands for Unicode. Now, before we can get into all the details and what it does and how it works, we probably should talk about Unicode for a little bit, just to make sure we're all on the same page and everyone understands what I'm talking about. So Unicode is kind of a database that maps any symbol that you can think of to a unique canonical name for that symbol, and also a unique number called the code point for that symbol. And here's some examples of that. So this is very useful because it allows you to refer to a specific symbol without having to use the symbol itself. You can just use the code point value or even the name, and then people can look up exactly which symbol you're talking about. Now there's, of course, a lot of symbols in Unicode. Here's just some examples. For example, the Latin capital letter A has the code point U plus 0041. And code points are usually formatted this way. So they're hexadecimal digits with the U plus prefix. And usually there's 0 padded up to at least 4 hexadecimal digits as well. Now, there's a lot of other characters. For example, the Latin small letter A is a completely different symbol, so it deserves its own place in Unicode, its own code point, and its own unique name. And there's a lot of other symbols, like the copyright sign, but also symbols in other scripts that maybe I don't use in my day-to-day communication, but things like the Greek small letter pi, or the tetragram for sender, or recently, more and more emoji are being added to the standard, like the pile of poo, for example. All those things are valid Unicode symbols, and they all get their own code point. Now, Unicode contains a lot of code points. The range goes from O to 10FFFF. So that's a little over 1.1 million possible symbols. That's a lot. So to keep things a little bit organized, Unicode divides this huge range of code points up into 17 so-called planes. And each of these planes contains about 65,000 code points. But the very first plane is probably the most important one. It's called the basic multilingual plane. And I said it's the most important one because it contains all the most commonly used symbols. So in fact, whenever you're writing a text document in English or even in Romanian, you probably don't need any symbols outside of this plane. Now, all the other 16 planes combined, they have a group name as well, and they're called the astral planes. So keep in mind that all of these astral code points combined, there's still over 1 million of them in total. So you cannot ignore these astral code points because they're the vast majority of the Unicode standard. Now, I gave a presentation before titled JavaScript has a Unicode problem, which talks about strings in JavaScript and all the problems involving Unicode in JavaScript strings and how you can work around them. But I'm not going to repeat all these examples here because I want to talk about regular expressions today. But just to give you a sample of how the misery starts, if you take an astral symbol like the pile of poo, for example, wrap it in a string, and you get the length of the string, the result is 2 instead of 1, even though there's only a single symbol there. And that is because JavaScript treats these astral symbols as if they were 2 individual characters, and exposes these separate characters individually. And this is called a surrogate pair. So each half of a surrogate is considered to be a separate character as far as JavaScript is concerned, which is, of course, very unfortunate and very confusing, and it leads to a lot of problems. Now, if you're interested in all these problems and how you can avoid them in strings, you should check out this presentation. But today I'm going to talk about regular expressions. So let's just see what this new flag, the U flag for regular expressions, enables for us and why we should be using it. So it has a certain impact on syntax. Then we will discuss what it does to the dot operator. It does something to quantifiers as well. Character classes get new behavior with this flag. Character class escapes as well. The I flag gets a slightly different behavior as well. And strangely, HTML documents are impacted by this change as well. And finally, we'll take a look at browser support and how we can make sure we use this feature without impacting our browser compatibility. So let's start with the impact on syntax. Now, adding the new Uflag to a regular expression unlocks a new syntax called Unicode code point escapes. It starts with a backslash followed by U, followed by braces. And between those braces, you can use any amount of hexadecimal digits that you want. And of course, you only need 6 to represent any Unicode code point whatsoever. So this gives you a really easy way to represent any Unicode symbol whatsoever by just referring to the Unicode code point without having to use the symbol itself. Now, these escape sequences are available in string and template literals as well, but if you want to use them in regular expressions, you have to opt into this new functionality by using the Uflag. And the reason for that is because you can do things like this as well. And it may look like you're able to use these Unicode code point escapes even without the Uflag, but that's not actually the case. For example, this code does not throw an error, but it also doesn't do what you would think it does. In this case, the backslash followed by the U is actually just an escape sequence for just the U character. So this becomes just a U, and then the braces and the numbers wrapped in the bracers, they become a quantifier. So instead of matching the code point U plus 1, 2, 3, 4, you're actually matching the letter U repeated 1,234 times exactly, which is not what you intended to do in the first place. So even though this seems to work because the code doesn't throw an error, it doesn't do what you want to do. So always opt into the Uflag if you want to use these escape sequences. And for this reason, you shouldn't blindly just add the Uflag to all your existing regular expressions, as tempting as that may sound, because it might accidentally change the meaning of your regular expression and break your code because of it. Now, one feature of the Uflag is that it disallows these useless backslash escapes. So if you do something like backslash A in a regular expression, well, there's really no reason why you would want to do that, because A is not a special character with special meaning in regular expressions. So you don't need to do that. You can just use the A character itself, and it doesn't do anything special. So if you try this in a regular expression with the Uflag, it will now throw an error. So you can think of the Uflag as kind of a strict mode, but for regular expressions specifically. And for that reason alone, I think that's a very good reason to start using this Uflag whenever you can. And this particular feature might seem a little bit of an edge case and maybe not that useful, but it's actually very, very important that this was decided, because this also makes it possible to extend the syntax for these U regular expressions in a future edition of ECMAScript. So for example, if someone were to write a specification that gives special meaning to backslash A, for example, well, it means we can now implement this in the future, because then it means we can go from throwing an error to doing something useful. And that is possible without breaking backwards compatibility. So this feature makes the Uflag actually future-proof. And by using the Uflag today, you unlock tomorrow's features in your regular expressions. Now, without the Uflag, the dot operator in a regular expression matches only BMP symbols, except for line terminators. So if you try a regular expression like a.b and you try to match the string a tetragram for center b, it won't match, because apparently the tetragram symbol is an Astro symbol, and JavaScript considers that to be two separate individual surrogate halves, which is not what you would expect, right? This is just a little bit confusing. Now, if you enable the Uflag, though, it works the way you would expect it to do. So with the Uflag set, the dot operator matches those Astral symbols as well. Now, quantifiers are also impacted, and quantifiers are things like the asterisk or the plus sign or the question mark or numbers wrapped between braces. They indicate how many times you want to repeat a certain part of your regular expression. And in this example, we're matching two consecutive A symbols. And the result is true because the string matches the regular expression. However, if we try to do the same thing with a different symbol, which happens to be an Astral symbol, it doesn't work that way. Once again, because JavaScript considers this regular expression to be similar to this example, where you see the two halves of the surrogate pair exposed separately. So instead of repeating the entire symbol, it's only trying to repeat the last part, the last surrogate of the pair, which is not what you tried to do in the first place, and that's why the result is false instead of true. So this is really confusing, and this is probably not the behavior you would expect. And well, at this point, it probably won't surprise you that you can fix this magically by just enabling the Uflag. This automatically makes it work the way you would expect this to work in the first place. Now, there's a certain impact of the Uflag on character classes as well. So in a regular expression, you can use these braces, well, the brackets, really. And if you do things like B, C, and D, it means I only want to match one of those characters, but nothing else. And that's why A won't be matched, E won't be matched, but B, C, and D will be matched in this example. However, if you try this with an Astro symbol, so let's just add a symbol there that happens to be an Astral symbol, it won't actually work the way you want it to work. It won't match the symbol itself, once again, because JavaScript considers this symbol to be two individual characters, even though that is really not true as far as Unicode is concerned. So the engine now tries to match each surrogate half individually, and the character class now contains not 3, but 4 characters as far as JavaScript is concerned, which is really surprising. Now, all these problems can be avoided if you just use the ECMAScript 6 Uflag instead. It makes it work the way you would want it to work in the first place. And this also means that whole Astral symbols can be used in character class ranges as long as you set the Uflag correctly. So instead of creating a range from B to D, for example, you can also create a range from one emoji to the other, and it will match all the code points in between that range according to the Unicode standard. So this regular expression matches the pile of poo, the flexed bicep symbol, and the dizzy symbol, apparently. And this works fine, but if you were to try this without the brand new Uflag, it would actually throw an error. Just a regular expression, it wouldn't even parse correctly. It would say, there's a syntax error, the range is out of order in the character class. And that happens because, once again, JavaScript thinks that each of these Astral symbols consists of 2 individual characters, and then it tries to create a range between one surrogate for the first emoji and the first surrogate half for the second emoji, which is not the range you wanted to create in the first place. And because in this case, the first number is greater than the second one, it also throws this error. Now, another thing that is affected is negated character classes. So if you do something like this, where between the brackets, you have a caret symbol followed by a list of characters, in this case only the A character, it means you want to match everything except for the A character. But without the Uflag, it will actually match only BMP symbols except for the A character. So it won't ever match an Astral symbol. And remember, those are over 1 million symbols in the Unicode standard that just won't be matched by this regular expression, even though you might expect it to. So with the Uflag, the very same regular expression matches the much bigger set of all Unicode symbols except for A, which is probably what you meant when you wrote this regular expression in the first place. Now, there's also an impact on character class escapes, and these are things like \d in lowercase or uppercase, \s for white space, or \w for word characters, which apparently are numbers from 0 to 9, letters from A to Z in uppercase and lowercase, and the underscore symbol. So the Uflag affects these as well. See, without the Uflag, \D, \S, and \W match any BMP symbols that are not matched by the lowercase variants of these patterns. And this makes a lot of sense, right? Because they're complementary to each other. They're just a negated set of one another. But with the Uflag, these patterns, they match Astral symbols as well. So they will match a much bigger set of characters this way. Now, there was a proposal to actually change the meaning of \D and \W and even \B for word boundaries when the Uflag was enabled to make them more Unicode-aware. For example, \W shouldn't probably just match the ASCII letters from A to Z, but it could also match letters in other scripts and other languages. Unfortunately, that proposal was rejected, although it has recently gathered some new interest, so maybe someday it will be implemented in some form. But there's another very important gotcha with this sort of functionality. There's this thing called case folding, which is the act of converting uppercase characters to their lowercase form according to the Unicode standard. And when both the I flag for a regular expression, which stands for case insensitivity, is set along with the U flag, then all the symbols are implicitly case folded before they are being compared. And this might sometimes lead to surprising results. And this, in my opinion, this is yet another reason to not blindly just add the Uflag to your existing regular expressions, because it might slightly change their meaning in a way that you didn't anticipate. For example, here I'm creating a regular expression that matches all the characters from A to Z in lowercase, but I use the I flag to match capital letters A to Z as well. Now, when the U flag is enabled as well, it will suddenly match the code point 017F and 212A as well, which is a bit weird and probably not what you would expect. Now, the case folding that I talked about, it applies to symbols in the regular expression pattern as well as the symbols in the string to be matched. So it goes both ways, which also can be a little bit confusing. See, if you use these code points that are outside of the ASCII range and you try to match it on a capital letter K within the ASCII range, for example, when both the U and the I flag are enabled, the regular expression will actually match, which is surprising by itself. Now, this opt-in behavior of the case folding is useful in some cases, but in many cases it can also be very confusing, in my opinion, especially if you use it with things like backslash capital letter W. So by default, backslash capital letter W matches anything that is not matched by backslash lowercase w. So it matches all the non-word characters. But with both the I and the U flags enabled, the new Unicode-aware case folding logic kicks in. And that means that essentially backslash capital letter W and backslash lowercase w are no longer each other's inverse, which is really strange and weird in my opinion. So once again, this is yet another reason to not blindly add the U flag to your existing regular expressions. You have to be very careful when you're making changes like that, especially if you're using the I flag. Now, believe it or not, the existence of the U flag has its effect on HTML documents as well. There is this feature called the pattern attribute in HTML that you can add to an input or a text area element, and it allows you to specify a regular expression pattern that will be applied to validate the user's inputs. And the browser then provides you with styling and scripting hooks that you can use to make stuff happen based on the input's validity. So the U flag is always enabled, according to the spec, for regular expressions compiled through the HTML pattern attribute. Now, at the moment, only Firefox supports this in the stable channel, but Chrome 53 and Opera 40 will support this as well. So it's coming to more browsers soon. Now, what about other browsers? Well, the current version of Safari doesn't support the U flag, but the feature is enabled in the latest WebKit nightly builds. So we can only suppose that it's coming to a stable version soon. Other than that, all the other browsers support the U flag in their stable builds. The only problem is that the pattern attribute in HTML, it's not really supported across the board yet. Like I said, Firefox implements it, Chrome and Opera implement it in an upcoming update, but Edge and Safari still have to work on it as well. Now, what can we do about those other browsers that are not mentioned here, like current versions of Safari, but also Internet Explorer and other legacy environments? We still want our JavaScript code to be able to run in those environments, right? So how do we solve that problem? Well, I created a transpiler called regexpoo, which enables these regular expressions with the Unicode flag. It kind of translates them into equivalent but slightly longer regular expressions that are compatible with ECMAScript 5. So it allows you to write the code based on ECMAScript 6 using the U flag, and it will automatically convert your regular expressions to something that works today in all environments for you. And you may have noticed that both Babel and the Google Tracer transpilers already support the U flag as well, and that's because they're using regexpoo as an internal dependency. So if you're already using one of these transpilers as part of your build process, well, the good news is you don't have to do anything. You can just start using the U flag in your project, and it will automatically be translated when you run your build script. You can start using the U flag today. Now, here's a quick demo page for regexpoo. It transpiles these ES6 Unicode regular expressions as you type. So if you want to get a feel of how this works or what the output would look like compared to the input and how much simpler the input is really, this would be a good demo to check out. So as you can see here, I'm testing the regular expression that we used before, foo.bar, and you can see that the dot operator now matches a much bigger set of characters, including the astral range. So it actually does match the pile of poo as well this time. Now, so yeah, just to prove, there's an alert with a pile of poo for you. It actually works. Now, the bad news is that for some things, there is still no built-in syntax in ECMAScript 6, not even with the Uflag. For example, Unicode provides lots of data files for categories, scripts, blocks, and other properties based on characters, but there is no way to access that data directly in JavaScript regular expressions today. So for example, let's say you want to match all the Unicode symbols in the Greek script according to Unicode. Well, one way to do this is to use a third-party library like xrayx, which enables you to do something like this. So you pass in a string literal that represents a regular expression pattern, and within that pattern, you can use a backslash. Well, in this case, you would have to escape the backslash. That's why there's 2 backslashes, followed by p, followed by braces. In between those braces, you can name a Unicode property or the name of a Unicode category or a script, like in this case, and it will match all the characters within that property according to Unicode. So if you try this regular expression that is compiled dynamically on the symbol pi, for example, it will actually match. So this is very nice, but the only downside is that xrayx is a 35 kilobyte dependency that you need at runtime, even after minifying and gzipping it. So this might not be an ideal solution for performance-sensitive code. Now, luckily, there is another way to do this. You can pre-compile the regular expressions and then use those compiled regular expressions in your source code. And there's a library that you can use to do this. It's called regenerate. And it basically takes an array of symbols or code points, and it will then create a regular expression pattern for you that only matches those symbols that you tell it to match. There's another set of NPM modules available that contain all this Unicode data that I mentioned before. So here I'm requiring basically an array of all symbols in the Greek script according to Unicode version 6.3.0, just by writing that one line. Then I pass in that array of symbols to regenerate. I call toString on it to turn it into a regular expression pattern. And just like that, you have a very complex regular expression that no one would like to write out by hand. But if you actually look at the 4 lines of code that generate this regular expression, that's actually fairly readable and very maintainable. So if you ever need to support complex Unicode-aware regular expressions like this, don't go crazy. Don't try to do it by hand. Use a build script for this, and then write the results to a file that you can then use as part of your source code. Now, you may have noticed that I'm actually using the data for Unicode version 6.3.0 here. And this is an outdated version, so this regular expression could also be outdated. Maybe there have been new symbols added to the Unicode standard that I also want to match. Because the latest version of the Unicode standard right now is version 8, but in just a couple of weeks, in 2 weeks actually, version 9 of Unicode will be released. So let's say you have to update your regular expression. Now imagine if you only have the generated regular expression there, and you have to update this for Unicode 9. It would probably take you a very long time to do this, and even to test it and make sure it works properly. But now that we have those 4 lines of code that generate the regular expression, it's actually super easy to update this. All we need to do is change the version number on the second line to Unicode 9, run the script again, and just like that, we have our new up-to-date regular expression. So once again, don't write regular expressions like this by hand. It's insane. It's crazy. Now, it would be really nice if, at some point, we wouldn't have to write these build scripts anymore, if we could just do this at runtime, but without introducing the overhead of a library like xrayx. So it would be nice if some future version of ECMAScript would support a syntax which allows you to do backslash, followed by p, followed by braces. And between the braces, you can then specify a pair of Unicode property and Unicode property value, and that will match all the symbols that match the pattern that you provided. And this is what that would look like. As you can see, it's much simpler to write. You don't have to write a build script anymore, even though the build script was already pretty simple. But you can just write this, and it would work directly in your JavaScript engine. That would be pretty nice, right? And maybe a better example for this audience is this one. My hovercraft is full of eels in Romania. Let's say you want to match all the letters, including the ones with special accents like the ones you're using in Romanian language. That would be actually pretty tricky to do if you had to write a regular expression for that yourself. But based on this Unicode data, you could just write a regular expression and tell it to literally match anything in the category named letter, and that would automatically take care of that for you. So this would actually match the whole sentence that we have there, including the weird Romanian characters that I would personally never use in my language, for example. So hopefully you agree that this feature would be nice to have and it would make a lot of things much easier. And even though it's already possible today to achieve similar behavior by using a build script and then inserting a huge regular expression into our source code, this would be much simpler, much nicer, with much less overhead. And in fact, there is already an experimental implementation of this particular functionality in V8. It's behind the Harmony regexp property flag. And there's also an experimental implementation of it in my Transpiler, which you can enable by passing an options object with Unicode property escape set to true. Now, the reason these implementations are experimental is because there's not really a spec for it yet. It's not official. It's not sure that this will actually be added to the spec at some point. But I have high hopes. I think this will eventually happen. And just earlier this week, I actually started to write a spec proposal, well, a first draft of what the spec text for this feature would look like. And I already got some positive feedback. So I think this will happen sooner rather than later. But if you want to use this for your projects, keep in mind that the syntax is not set in stone yet. It could still change. So what ends up in the ECMAScript language or in JavaScript itself might not be exactly the same as what V8 or regexpoo implements right now. Keep that in mind. Now, if you go back to the demo page for regexpoo, you can already play around with this functionality as well. So for example, here I'm just writing this very simple regular expression that tells the engine to match all the symbols in the Greek script. And as you can see, it gets compiled into this huge regular expression that we saw before. But this regular expression at the bottom actually works today. So by using this transpiler, you can already get a feel of what it would feel like to write code using this particular functionality without it affecting your compatibility with existing browsers and Node.js. So to summarize the takeaways here, I think you should use the Uflag whenever you can. So for every new regular expression that you create, you should always start with the Uflag. Now, you should remember the Uflag is to regular expressions as strict mode is to all of JavaScript. So even for that, it's a good enough reason. But also remember that the Uflag, the presence of the Uflag itself, enables syntax extensions. And there's more syntax extensions to come that will be added to the language as the P escapes that we looked at earlier, for example. So by using the Uflag now, you make sure that you can use these new functionalities as soon as they're added to the language. At the same time, though, you shouldn't blindly add the Uflag to your existing regular expressions. You should be very careful when you're updating your existing code, because you might accidentally end up changing their meaning. Now, of course, you should be using a transpiler, not just for regular expressions, of course, but in general, if you're using ECMAScript 6 or even ECMAScript 2016 or ECMAScript 7 features, you should be using a transpiler anyway, because you want this code to run even in older environments that don't understand all these features yet. And remember, both Babel and Tracer support the Uflag already, thanks to their integration with regexpoo. And finally, you should use xrayx or regenerate build scripts or regexpoo in experimental mode with the experimental P escape syntax to do anything that the Uflag cannot natively do yet. And well, you could also just cross your fingers for this functionality in the next version or some future edition of ECMAScript. That would be nice to have. By the way, the fingers crossed emoji is actually new in Unicode 9, so it should be coming to your computer and on other devices in the next couple of weeks. So yeah, thanks for listening.